And this is a unique problem because, well, we'll see why when we do the work, but we do want our answer as a mixed number. Now the process is not going to change, and we'll see, well, at least the first step here. So I'm going to take 4 and 8/9 and change it into an improper fraction, right, using cycle method. So that'd be 4 times 9, which is 36, plus the 8 numerator. 6 plus 8 is 14, carry the 1. 1 plus 3 is 4, so I get 44 as my numerator of the first fraction there. And yes, the denominator stays the same as 9. All right? And then the second fraction, cycle method once again. I got 7 times 9, which is 63. Excuse me. And we need to add the numerator, 5. So 3 plus 5 is 8. Nothing to carry, it's just 68. So I have 68/9. Now, what we get on this one is denominators that are already matching, which means we do not need to change the denominators, which for me, I like these types of problems because it makes things extraordinarily convenient, because we can go straight into the operation phase. So I'm going to take the two numerators, 44 and 68, and add those together. Let's see what we get. 44 plus 68 here. 4 plus 8 is 12, carry the 1. 1 plus 4 is 5, plus 6 is 11. So I get 112 ninths, of course, because 9 denominator will stay the same. And when I first saw this with the other class, I saw, well, maybe this is divisible by 3, but it's not actually, although 9 is, which means this is not simplifiable. And so all we need to do at this point is change that improper fraction into a mixed number. So I'm going to use some long division. 112 divided by 9. Yes, this will generate a mixed number for us. Of course, the denominator will not change. It's still the denominator of 9. Our quotient is the mixed number. The remainder is the numerator of the fraction. So I would look at this and say, well, 9 doesn't go into 1, but it does go into 11 once. 1 times 9 is 9. I subtract that. 11 minus 9 is 2. Drop this 2. There. And I get 22. 9 goes into 22 2 times. 2 times 9 is 18. When I subtract that, I get 4. I borrow from the 2 there to make that. 12 minus 8 is 4. And, well, that's our remainder. I'll do it in a different color there. The remainder is 4, so that's our numerator. And our quotient is 12, so I have 12 and 4/9. Again, just make sure you do this in the end. Just make sure your fraction cannot be simplified, and 4 over 9 is not simplifiable, which means we've reached the end. 12 and 4/9. Let's just say that you scaled these, right? Let's say that you said, well, I did 9 times 9 and 9 times 9. Now you'd end up with a denominator of 81. I don't know my 9 multiplications tables up to 44 or 68, but you'd end up with some pretty big numbers there. And of course, whatever value you got from that would be simplifiable. Eventually, if you simplified it enough, you would get the same improper fraction that we had right there, 112 over 9, which then I would recommend doing the long division. It's not like you have to wait that long to do the long division, though. But whatever you get or whatever you did in between here is not as important as seeing that the answer is the same, 12 and 4/9.